Hello everyone, my name is Alicia Dita, or you can call me Dita, and I will be your physicist for today. I will be explaining about wave interactions today. So before we start, I'm going to explain what is wave interaction. So wave interactions is how waves behave when they encounter each other or when they come across obstacles or a boundary. Next is types of wave interactions. There are a lot of types of wave interactions. There are five here. As you can see, the first one is reflection, second one is refraction, the third one is diffraction, the fourth one is interference, the last one is Doppler effect. But today I will be only explaining two of them, which is reflection and interference. So let's get started on reflection first. So, what is reflection? So, reflection is when a wave strikes an object or surface and bounces off. Also, waves bounces back at a boundary. So, we can see here on the diagram how reflection works. I'm going to explain it. So, first, I'm going to explain about the incident wave. So, what is the incident wave? So, this is the wave of light that hits an object surface. The arrow shows the direction the light travels. And then I'm going to explain about the reflected wave. So this is the wave that bounces off the object and travels in a new direction. And then we can see here the thing on the bottom. That's the point of incidence. So that is the exact spot where the incident wave strikes the object's surface. So now I'm going to explain the real life example of reflection. So reflection is everywhere in our life, really. I'm going to start with the most basic example that we use in our daily life. So that example is when light travels towards your eyes. So when light travels towards your eyes detect this reflected wave and your brain interprets the information, allowing you to see objects and the color of the object. Yeah. Let's move on to interference. So, what is interference? So, interference is the phenomenon in which two or more waves superpose to form a resultant wave of greater, lower, or the same amplitude. So, we can see from the diagram here, there are three waves. So, there are the green, blue, and red waves. So, first wave is the green wave, and the second wave is the blue wave. So when the green wave interacts with the blue waves, it creates another wave, which is the red wave. And the red wave is actually the sum of wave 1 and wave 2. Now, moving on, I'm going to explain the real life example of interference. But before we talk about the real life example, I'm going to explain to you the types of interference. So there are two types, which is constructive interference and destructive interference. So constructive interference occurs when two waves are in phase, meaning their peaks and troughs align perfectly. And there are destructive interference. So destructive interference is when the peak of one wave overlaps the trough of the other. This creates a partial or complete cancellation effect. The resultant wave exhibits a weaker amplitude or can vanish entirely if the waves perfectly oppose each other. So I'm going to explain the real life example now. So it's the noise cancellation headphones. So these headphones use the principle of destructive interference, like I explained before. So tiny microphones pick up ambient noise, and the headphones emit sound waves that are essentially out of phase with the noise. These opposing waves interfere destructively, significantly reducing the noise reaching your ears, letting you focus on your music or your audiobook. All right, that's it. Uh, that's it about wave interactions. I'll see you on the next video.